Question 2, and I'm always going to draw a diagram with these things because I think it helps. I'm not interested in particularly where these points are. I'm just drawing this triangle because it says it's going to be a triangle. So let's find out. I'm putting the coordinates on, and notice I'm putting them horizontally, so they are coordinates. And I'm going to work out what the vector from A to B is. So the vector that takes from 2 to 4 is 2, from 1 to 4 is 3, and from 5 to 3 is -2. So there's that vector there. Let's do all of them. I'm going to do B to C as well. B to C as well. So from 4 to 2 is -2, from 4 to 7 is 3, and from 3 to 5 is 2. Now, I don't really need to do a lot of maths here to actually spot that these two are both going to be the same because they've virtually got the same numbers, just some negatives there. Let's do A to C as well. A to C is from 2 to 2, so that's 0, from 1 to 7, so that's 6, and from 5 to 5, so that's 0. So, look, to show its isosceles, let's find out the length of A to B. The length of A to B is the square root of 2 squared and 3 squared and -2 squared. So I've got 9 and 8, 17. And the length of B to C is the same thing, isn't it? And the length of A to C is actually different, isn't it? This length here is clearly just 6. So two sides the same, two sides, same length, therefore isosceles. Now part B says find the area of this triangle. And so what I'm going to do to find the area is I'm going to bring the perpendicular down here to find out what this height is. I'm going to look at that triangle there. And we already know that, well, we can tell here the distance there to there is just going to be half of the distance of the whole thing there. So that distance there is 3. This distance along that diagonal there we've done earlier is root 17. So I'm going to use some Pythagoras to work out what this distance here is. It's going to be this squared, which is 17, take away this squared, which is 9, square rooted. So 17 take away 9 is 8. So I've got the height here is 8. And the area of the triangle will now be a half times the base, which is 6, times the height, which is root 8. And so what have I got? I've got 3 root 8s. Might play about with the surds as well there. Of course, root 8 is 2 root 2s. And so my final answer would be 6 root 2s. Now for part D, I'm going to get rid of all this working, so go back to my diagram. And I can see that A, B, and C are already there. I'm going to get rid of that one there. We'll get rid of that height that we just put there as well. Let's get rid of all of that. And A, B, C, you can see where D is going to be. D is going to be over here. So that this line here is parallel to this line here. And this line here is parallel to this line here. Now we've already done what B to C is here. It's -2, 3, 2. So this journey here will be -2, 3, 2 as well. Well, 2 take away 2 is 0. 1 and 3 makes 4. And 5 and 2 makes 7. And so there's my point D, 0, 4, 7. We could check that by looking at this right line here as well, because we know that there to there is 2, 3 minus 2. Let's check. If you add 2 to that, yep. If you add 3 to that, yep. And you add -2 to that, you get that one there as well. So the other way of doing it would have been to start here and do that vector in the other direction. But either works, and there's our point D.